Hello there, welcome back to Technology Innovation Hub. It's going to be a session from Oracle portal. Let me share this screen. If you can remember, we have been doing this one. I think this is Oracle portal. We have been doing CP3 lesson 4. That is what been completed. In that, you may remember we discussed the ADR, init parameter, and alert file troubleshooting. And again, I think we discussed the impact of discontinuation on this Flash support and how it's impact to DB console as well. And we discussed a lot of things. So that is that. And up next, I mentioned on the same video end of CP3 lesson 4, I mentioned the next one will be Oracle database architecture. Yeah, so that is what is going to be the most wanted, the most demanded Oracle database architecture series. So let's start that one right away. Now this series, I'm not going to categorize in any of these CP series because now by now you know how the videos are being published in the channel. Most of the videos are being categorized either CP1, CP2, or above CP10 for mid-series, mid-senior level, and above CP20 for more senior and about 10 years experience resources. But this architecture series, irrespective of CP levels, I mean, whether you are a beginner, middle level resource in the industry, or a more senior, I'm recommending for everyone to go to this one, and I need your comments on this. So because it's so important, Oracle database architecture. When you develop in a carry with Oracle database, this is like the foundation. This puts the foundation. Foundation in a sense, better the foundation. Even when you're building a house, how comprehensive or how powerful the strength of your foundation will be the strength of your house. So similarly, the better you are aware, better deep knowledge that you have on Oracle database architecture, that will allow you to build a better career on database track. Actually, now there is we won't be able to identify a specific database role in the industry. It is getting away since due to the automation, but still you need this architecture knowledge, especially when it's come to troubleshooting and error correcting and those things. Because if you don't know the architecture, tracing back issues, giving resolution, perfect resolution as a professional, you are going to, fall short. Your resolution, you won't be able to guarantee, right? You can't say like, as a professional, you should be able to guarantee a completion of a task, and should be able to tell this is the right way without any clues, and you should be able to tell it should be completed within this time frame or a plus or minus estimate kind of a thing. So that is a professional. Now to go to that level, this architecture is very important. Otherwise, you are going to fall short in your resolution or in your total solution. So that's why it's very important. So for everyone, beginner, mid, senior. So let's start this one, Oracle database architecture. So let me put it fully screen here. Yeah, I think it is clear. Now we are going to start with Oracle non-multi-tenancy architecture deep dive. Because I think on the very first stage of this Oracle portal also I mentioned, because our focus, initially we will be focusing on non-multi-tenancy architecture. Because we all know after Oracle 12c, they introduced the multi-tenancy architecture. But in the industry, still both are in news, and a lot of customers are trying to migrate, do this transition from this non-multi-tenancy to multi-tenancy. Multi-tenancy is not only from database level. Even though Oracle is giving true multi-tenancy architecture at the database level, where a lot of other databases do not do that. It's a separate topic. We need to open up a big discussion. What is a tenant and how we go to give you benefits. It comes with microservices architecture and a lot of things are there, right? So let's not touch that. So we are going to start with our traditional. Now we are telling is traditional database architecture because that was the architecture was available up to 11G. 11G. That doesn't say that 12C and 19C doesn't support the non-multi-tenancy architecture. Yes, it is there, but after 12C only this multi-tenancy architecture came, CDB and PDB architecture. So we are going to have a separate series about multi-tenancy architecture deep dive. That's going to be a separate series, but this series is going to focus on non-multi-tenancy architecture. I mean, for a resource, it is very important initially to understand this non-multi-tenancy architecture, because even within multi-tenancy architecture, the PDB, pluggable database architecture, is almost same for this non-multi-tenancy architecture or traditional database architecture that you are going to learn now. Because container database is having a different architecture, so that we will learn later, but a lot of similarities are there. Okay, so let's start. And I think as the very first slide, I have included certain things just to give you a know-how. I mean, as soon as you look at it, you see this component system global area, program global area, and data dictionary cache, and likewise HCA memory structures and the background processors. And from this side, you can see the physical database architectural components like database files. I mean, we know in Oracle database, there are key 3 file types: data files, control files, and redo log files. And these are password file and archive files. I mean, SP file, these things are key files, but not database files. So let's learn more details and let's start the architecture deep dive. Let me go to the next slide. All right, so this whole presentations, the whole explanation is organized in such a way. So that's why let's take a look at how this architecture journey of Oracle non-multi-tenancy database architecture, how the flow is going to be. So that is the purpose of this slide. Let's take a look at it. Theoretical understanding with definitions. Yeah. Because initially, now we have done a lot of practicals. You know that, I mean, if you just follow the series, the previous videos that we have been doing, a lot of practicals were involved. But that does, I mean, that doesn't say the architecture is now, as soon as you look at this, you may wonder this is going to be a total theory. No, it's not going to be like that. Architecture, we are going to have theoretical explanations as well as demonstrations. For example, when I'm talking about Oracle database instance, when I'm telling startup command, startup no mount, startup mount, so these things has to be demonstrated practically as well. So initially there will be some theoretical understanding because we need to understand. Now we have seen practically what is a database instance, startup and mounting and not. But when the database instance starts, what's happened in the background? What is going to be? There are certain memory components going to start, there are going to certain background processes going to start, and some interactions are there, right? So there are a lot of things happening behind the scene. So those things we need to understand in the architecture. So that's why very first thing is to get those understanding in theoretical way with the correct definitions. So let's see, right? And the next one is all about memory architecture. Yeah. So this theoretical explanation will be including about memory architecture, and we are going to have about process architecture. You know, Oracle has HGA memory, system global area, it has PGA memory, it has UGA memory. So likewise, those are very high level main categories. HGA, PGA, UGA, very high level main category. But we need to get into those things. What is HGA? What are the components of HGA? Where is PG? What are the components? What is the purpose of it? How it's going to work? How the components going to interact with each other? Likewise. And again, you know, process architecture, exactly. We have, all of you know about background processes, right? Because database writer, log writer, system monitor, memory manager. So those things everybody knows, but there are other side of processes like foreground processes, servers and all. So that's why we have a separate memory architecture, we have separate process architecture, and again we have physical database architecture as well. So let's take a look at it. Physical database architecture we are not going to touch in deep here, but we will give a explanation about data files and log files and control files and all, multiplexing and all, because those topics are going to be taken separately later. Data files, table spaces, log files separately will be break down into more details later. Then the client-server communication. Of course, a user before interactive in database, the login process has to happen. He has to log in and a session has to be established. He has to create a session. So how a session create? Then the listener process comes, user process, server process, right? And if it is a shared server, dispatcher is going to come. How those things are going to work? So that's why this client-server communication. Okay, then let's go to architectural component interaction with step-by-step SQL statement walkthrough. So this is very important. Having learned the theory, now by this time up to here, you will get to know all the definitions of the components. For example, if you get system global area, what are the components? You are going to have mem optimize and in memory, and you are going to have library cache, data dictionary cache within shared pool. You're going to have database buffer cache, redo buffer cache, like there are a lot of components within the SGA. So definitions are given by this time. When you start in this topic, you are all aware of the definition of the theory. Now here the purpose is getting the definitions to get an idea how those things are interacting each other. That is very important, because when there's an issue comes, you should be able to trace forward from a position and come back from that position. Let's say if the issue is there in an execution plan, you need to understand how this execution plan is generated, at which point it is generated, the composition of the execution plan. Likewise, you need to be able to understand. And what is pass, fetch, and execute? When a SQL command comes initially, what is the very first step that Oracle does? Then when an update command, when a select command comes, what is happening? When an update command comes, right? And what are these redo is doing when update, when a DML command is going? How is tracking the changes? When a commit happens, what's going to be? Because a lot of resources nowadays, they think like the other databases, even in Oracle, when a commit happens, it is updated in database files, DBF files. No, it never does that. So we need to understand these things. At commit, Oracle updates the redo log files. At checkpoint only, it's going to sync up. So we need to understand those in checkpoint mechanisms and how to optimize those things, pass start, MTTR, target settings, a lot of things. And this is going to be very important. And that is what architectural. So we are going to discuss those things, the component interactions each other. Checkpoint mechanism, I just explained. Now, again, we have DBAs, even the senior DBAs, more than 5 to 10 years experience. Still, some people are, a little bit afraid to type the old system checkpoint command even, because they don't know what's happening in the behind. So that's why we need to clear out those things. Checkpoint mechanism, very critical in Oracle database, and you need to tune up these parameters. So without getting the architecture, how the checkpoints are working, you won't be able to do that. To optimize Oracle database, actually, we have, let's say, first thing is we need to do core tuning. Oracle clearly says, calibrating pass start MTTR target parameter. They use that word, calibrate. That is core tuning. So without core tuning, we can't go for fine tuning. A lot of resources in the industry, they try to, okay, let's say if a particular table is slow, and if the database is slow, they will identify this table has more than, there are a larger number of rows in this table than the other. Then they will try to introduce partitioning and data distribution, a lot of things. But those are fine tuning techniques. Prior to that, core tuning has to take place. So core tuning is directly related with checkpoint mechanism. And if you look at the alert log file, you should be able to identify these things. Waiting for checkpoint, private flush not complete, checkpoint not complete. So these are symptoms of core tuning, lacking of core tuning. So to introduce core tuning, resource must be aware of how Oracle checkpoint works, how the pass start MTTR target parameter works, checkpoint timeout interval works. So likewise. So those things we are going to explain on this particular topic, checkpoint mechanisms, and we have different types of checkpoint, incremental checkpoint, pool checkpoints, right? So partial checkpoints like that. And the other thing is very important, DB writer, log writer conditions. When a DB writer fires, when a log writer fires, and the dependency, I mean, we have whenever before DB writer writes, log writer has to write. So let's understand those things. So there's a big connection between these two, log writer and DB writer. For example, this below may be having only 4 conditions, but this one may be having 9 conditions. But before DB writer writes, log writer has to write. So therefore, automatically this one will have 13 conditions. So let's understand those things. Let's try to clear those things. So detailed explanations will be done here. The conditions for DB writer, log writer to fire. And again, multiplexing into log file, very important. I mean, we need to prepare the database. If the database is a standalone database, we need to make sure the basic availability is there. And we need to understand the impact of not multiplexing into log files. If you are running with individual redo log files, okay, if a current log file crashes, that's we are going to face a worst scenario in Oracle database if a current log file crashes. The reason is our committed data is here. Earlier I mentioned Oracle commit will never update DBF file. It will update only the log files. So at commit, log writer updates the data into the current log file. So if you haven't multiplexed redo log files, then if the current log file crash, you might lose committed data because there's a little bit of gap. The checkpoint has to take place for data file to be updated to the latest committed data. If you haven't tuned up the checkpoint, if you depend on the default setting, which is I think 1800 seconds, so let's discuss those things, then you are in trouble. So to avoid this one, you need to multiplex redo log files. Multiplexing means having multiple copies of the same file distributed across multiple disk locations. So let's discuss on those things in more detail. Multiplexing log file, those are must, like fundamental knowledge. These are basics actually. So before talking about high availability, rack, grid, and data guard and all, these things are must. You need to clear out those things. Multiplexing log file and optimal log file. Yes, we need to set up optimal size for log files. And it depends on the parameters as well. You know, a lot of resources keeping this default log file sizes, 100 MB, 50 MB. It's never going to work, never work. This is depend on the business nature. A customer to customer, client to client, log file size will vary because there's a direct relationship between the amount of transactions they are doing per a second, log file size. We need to understand those things. So the setting given for one client will never match for the second client. You need to, as a DBA, you need to set the optimal log file size. You need to drop them and recreate with the proper size. There is a way to do that. There's a way to do that. Oracle VDR instance recovery view is given, there's a parameter called optimal log file size. But by default, it doesn't predict the value because you need to set MTTR for that. Once you set the MTTR, only start predicting those things. So without setting the MTTR, you can't do that. So we need to learn. That's why checkpoint mechanism, MTTR setting, you need to understand. So all comes on the architecture. Fine. So let's, okay, I have given a reference here. So while the explanations are going in, I can show you a reference. This is a very good reference. You can take a look at this one. I will let me show you that I have it open, I guess, right? Yeah, check that. Should see this one. Yes, this is what this is actually given. Oracle has this one from 19C onwards only. I think they have given this. 21C also have the technical architecture. They have given it a different format. This is just a PDF, but just go to it. Oracle database 19C technical architecture. They are explaining everything nicely. So in fact, I am also referring to this one, but I will be getting in more detail than this. Anyway, this is for a beginner also. This is very good. They are going to this sharp pool and likewise and about the background processes, and yes, about this program global area, and on the top you had about system global area, likewise. Just go to it, that one as well. And I have given another reference. This is nothing much, just a documentation. This is just a documentation, Oracle documentation, 19C1. Yeah, just go to that one as well. So those are the references for the time being, because everyone can access these are free. And I think I will explain most of the things. Whenever I need to prepare documents, I will tell you these are for you to begin, right? As an initial step, you can refer to these documents. Okay, hope we are good there. So that is the journey we are going to go through for the architectural explanation. Of course, overall, this explanation may jump to 4 hours, but as our regular practice, we are not going to do lengthy videos, maximum 15 to 20 minutes. So let's try to understand little by little on the architectural journey. I think let's go to the next slide. The next slide is right away starting Oracle Database Server. And what is Oracle Database Server and also we are going to start explaining the basics, database server and how it looks like. This is just a start, and later let's take a look, get into more details with architecture, basic memory structure, process architecture, and yeah, so we are going to get start deep dive the instance started, and likewise a lot of explanations to become. And this is about instant explanation. So I'll be taking through step by step with practical as well, and a lot of learnings are going to take place here. And this is just very first one, instant started, and after that, you know, the mounting will take place. Yeah, so likewise, so let's go to these things step by step. So startup command, so then we have the mount, database get mounted, and the control file gets open. So likewise, so let's go to these things little by little. Fine, I think let me stop here for this session, and I'll be starting from this slide on the next session. Fine, have a great time. I'll meet you soon. Bye bye. Thanks.